limits at infinity. So what happens if the value x approaches infinity? So for this case, how do we solve this problem? Well, first we gotta look at the denominator or the numerator and see which one has the highest power. And by reciprocating the fraction, so like in this case it's 3 to the power of 3, no, x to the power of 3. So what we do is we multiply both numerator and the denominator by the reciprocal of the highest power. So like this, in this case. So what we do is we multiply like this. Then what happens is then this happens. Right? Then we can cancel it out. So we get 1 over x squared, 0. Oh, never mind. This one stays like this. For this one, it's just 1 plus 6 over x squared plus 7 over x cubed. For x cubed here. Then what happens is that the limit x approaches infinity turns into this. Now we can analyze that as x approaches infinity. This 1 over x approaches 0, since 1 over infinity, as x gets bigger, 1 over x is going to approach 0, like 0.110001, or even smaller. And similarly, 1 over x squared will approach 0. 5 over x cubed will also approach 0. Let's get the denominator. 1 will approach 1. 6 over x squared will approach 0. 7 over x cubed will approach 0. So if we just fill it out, we get this. So it's this, right? So 0 over 1 is equal to 0. Therefore, limit x approaching infinity, f of x is 0. So another approach of solving this problem is by using what's called the end behavior model. We're going to look at the end behavior of this function, or of this limit, as x approaches infinity. So we can tell that for denominator, highest power is power of 3. For the numerator, the highest power is power of 2. What we can do, since the x is approaching positive infinity, we can just do this. Because infinity cube is going to be really big. It's going to be bigger than infinity. So x approaching infinity, or 6x approaching infinity, right? So as x is going towards infinity, x to the power cube and x to the power square, x to the power of 2 will make the overall shape of the function. So we can just do this. This is what the function will similarly look like as it approaches infinity. So from very far away, if you look at the function, it will pretty much look like this function. So if we cancel it out, we get limit x approaches infinity, 1 over x, and as x approaches infinity, it's going to be 0.